We're now going to cover the last part of inference test for means. This is a matched pair significance test. So this is one of those ones where we have two samples. However, we're not going to treat the two samples as two different samples. What we're going to look at is the difference between the two samples. So let's go ahead and take a look and see what we got. So looking at the problem states that a patient who had undergone a triple coronary artery bypass was tested in the following way. The patient took his pulse at rest and then on a treadmill. This was repeated on 6 different days. The pulse rate 6 minutes after the test and the pulse rate before the test are shown below. Do these data indicate that the population mean heart rate 6 minutes after the test is higher than before the test? Okay, so basically what we're finding out is that this is called a matched pair. And the reason that this is called a matched pair is because each one of these tests, 1, 2, 3, 4, 5, 6, is done on the same individual before and after. So this is their before rate, they get on the treadmill, this is their after rate. So what we're doing is we're trying to see if there is a difference in their pulse rate from before and after. So even though we've got two samples, we're going to be treating the mean difference, not the difference in means, okay? Because this is my mean before, this is my mean after. So if I have this, we're going to go ahead and do the same way P. We are going to be looking at the difference between these two. So I don't really care about their before and after. What I care about is this. Mean difference is the mean difference in pulse rate before versus after the treadmill. Okay, so again, what I'm going to care about is the difference between these two. So my null hypothesis is that there is no difference. My alternative is it's higher than before, that the population is higher than before the test rate. So basically what we're saying is that that mean difference is greater than 0. And if we really want to think about it, what we're talking about, the mean difference, is that when we do before minus after. So in this case, what we want to do is, I'm sorry, take that back. If we want to see it's higher, we do after minus before. After minus before. My mistake, it's after minus before. So our assumptions. We are going to check and see if this is random. And in this case, repeated on 6 different days. It's not stated, but I'm going to assume random. I'm going to assume that your pulse rate is random on any given day. Independent. This is an experiment. I'm imposing a treatment. The treadmill is the treatment. So I'm going to say that results on each day are independent of each other. That your pulse rate on Tuesday has no bearing on your pulse rate on Thursday. Okay, and then large enough. Here is the deal. I only have 6. So I got to look at something visually. So what I'm going to do is, this is a small sample size. This is a small sample size. So what I'm going to do is I'm going to look at the difference between after minus before. So if we think about the difference here, 85 minus 69 is 16. 79 minus 72 is 7. 83 minus 75 is 8. 84 minus 73 is 9. 87 minus 70 is 17. 78 minus 74 is 4. So this is one of those ones, again, with a smaller sample size. What I'm going to encourage you to do is just to do a dot plot. And it looks like I go from 4 to 17. So what I'm going to do is the following. I'm going to do 4, 8, 12, 16, 20. And we're going to call this difference in pulse after minus before. And we're going to go ahead and put the dots down. So we got a dot at 16. We got a dot at 7. We got a dot at 8. We got a dot at 9. We got a dot at 17. And we got a dot at 4. And in this case, I'm just going to say, it's very, very difficult to see any outliers. So I'm going to say I see no strong skew. I see no outliers. Again, if you want, you can put it in the calculator and look at it, but I will tell you, when you deal with smaller sample sizes, oftentimes it's harder to see that skew. Outliers maybe, but I'm going to say just because there's 2 out there, I'm not going to necessarily say that 2 of 6 are outliers. That seems kind of unlikely. So N, we're going to conduct a 1 sample t-test for true mean difference at alpha equals 0.5. And now we're going to do t. And the way we're going to do t is we're going to get that formula. We're going to plug in the numbers. It's x bar minus mu. So it's x bar difference, mu difference over the standard deviation difference over the square root of the sample size of the difference. So what we're going to do is this. We're going to do second plus 7, 1, 2. We're going to go to stat. We are going to go to tests. We're going to do a 1 sample t-test. We're going to actually put in the data first. My mistake, stat, edit. And we're going to put in all of those differences: 16, 7, 8, 9, 17, and 4. So I put the 6 in. Now I'm going to do stat test number 2. I'm going to run it on the data. My mean is that their difference is 0. The list is in L1. We're trying to prove that it's greater. We're going to calculate. And what we're going to find out is that our t statistic is 4.79. But if you notice, we got everything in here. We got our x bar, we got our sx. So in this case, to fill in the blanks, my x bar difference is 10.17 minus 0 over my standard deviation is 5.19 divided by the square root of 6. That is going to give me a t statistic of 4.796. It's going to give me a p-value of 0.0025. And the one thing it does not have on here that we need to put down is that the degrees of freedom of the difference are going to be n-1. So it's 6 minus 1, it's 5. So it's telling me that these degrees of freedom 5 give me that p-value. I'm going to make my decision. Since my p-value is less than my alpha, this is a reject the null situation. So now what we're going to say is, since p-value of 0.0025 is less than alpha of 0.05, we reject the null hypothesis. There is evidence to support the claim and I'm going to steal right up here, that the population mean heart rate 6 minutes after the test is higher than before the test. So basically what we just proved is that running on the treadmill increases your heart rate. That is a matched pair test. Again, the reason that it's a matched pair is because we have 2 samples, but we don't treat the 2 samples as individual samples. We look at the difference as 1 sample. So kind of like we did with the intervals, but now we're doing it as a test. So that's the last one. So Realistically, in this unit, we've actually had 3 intervals and 3 tests. We had a 1 sample interval where we were basically trying to come up with the best idea, best guess of a mean, a range of values of mean. We had a 2 sample interval. The 2 sample interval is where we were comparing 2 samples to one another, and we were trying to see if they were different from one another, looking for that 0. We did a 1 sample matched pair interval where we had 2 samples that were paired in some way, and we looked at the differences of 1 sample, and we were looking for 0 in that 1 sample. And then we did the equals for tests. So we did a 1 sample test, we did a 2 sample test, and then we did a matched pair, mean difference test. We're going to review on Friday. I'll give you the review guide today. And we are going to take our test on Tuesday. It's just going to be the FRQ test. So please let me know if you have any problems or any questions. And we're just about done.